Hello, and welcome to Climate Fix Podcast. Here we dive into evidence-based solutions to climate change and various other pressing environmental issues. This podcast is created by Americans for Nuclear Energy, a pro-nuclear environmental organization. We take no money from industry or special interest groups. All donations are from individuals like you, interested in a grassroots scientific movement to solve the world's most pressing scientific problem, global climate change. We hope you approach these ideas with humanism and an open mind. Our mission statement is as follows. Nuclear energy is safe, cheap, plentiful, clean, and efficient. It has the capability to stop and reverse climate change while addressing the ever-growing demand for electricity globally. We strive to educate American citizens about this technology and to dispel misconceptions with facts. We firmly believe that both human civilization and industrialism can easily coexist with a healthy environment. Join us in helping to plan a prescription for a feverish planet, or as we like to say, a climate fix.
This is your host, Phil Ord. We are doing something a bit different this episode and hosting a nuclear engineer roundtable discussion with 3 guests in that sector. Today we talked to Mack Cullison, Sarah Woolf, and Jason Simental about why they came to the field, what it brings to the climate change mitigation effort, and its future as a field for young people to enter. Here is some background on our guests. Mack Cullison is a nuclear engineering PhD candidate at Oregon State University. His studies focus on nuclear materials science, specifically material response to radiation environments. He is a published scientist with work on uranium-zirconium alloys. Furthermore, he posts YouTube videos and connects on Facebook to engage viewers and readers to spread nuclear knowledge. Sarah Woolf, Director of East Coast Operations at Mothers for Nuclear, is an environmentalist and advocate for nuclear energy. She has worked as an engineer in the U.S. commercial nuclear fleet for the past 9 years. Currently, she is an Inspection Codes Programs Engineer for Exelon, where she assists plants in managing and navigating code compliance and inspections to ensure error-free operation. Sarah moved to New York State from Wichita, Kansas, to get her degrees in mechanical engineering and journalism at Rochester Institute of Technology. She has a strong passion for advocating to maintain our existing commercial nuclear fleet, as well as for the introduction of new nuclear energy technologies. She hopes to continue reaching people on a personal level to show why nuclear power is an essential part of a clean energy future. Jason Simental has a bachelor's degree in nuclear engineering technology from Excelsior College and received an instrumentation and controls apprenticeship at Palo Verde Nuclear Generating Station. He has 6 years of experience as a technician. He's currently working on expanding his engineering acumen outside the nuclear industry, but hopes to make a return when advanced and small modular reactors begin construction. As we all know, if you haven't been living under a rock, we are under threat of climate change resulting from emissions of greenhouse gases from energy production. Nuclear power is clean, powerful, and produces no greenhouse gas emissions. Thus, the engineers and technologists in the nuclear field are participating in the decarbonization effort. Our guests have careers or are pursuing careers in this promising area, but its future remains uncertain. Our hope is that more people will see the importance of nuclear power in the climate fight and inspire people to enter the field. Nuclear engineering and technology offers so much, but it is only viable if politicians and our culture at large facilitates its success and looks upon the technology in a positive light. The sector is very complex and requires large amounts of scientific knowledge. Clearly, anyone who puts themselves through the rigors necessary are dedicated to the cause. If it were up to us, nuclear scientists and engineers would be considered climate heroes for taking on the problem of greenhouse gas emissions threatening to overheat our planet into oblivion. Getting to talk to such guests is an honor and a privilege. What they do takes a lot of work and deals with things much more complex than the average person can even comprehend. Being in a group of people actually physically preventing greenhouse gas production seems like one of the coolest jobs in the world right now. I'm eager to hear from all these talented individuals and get their perspective. We are in a critical time in human civilization. and the nuclear industry is poised to be a very large player in the world's energy future. So let's get right to it and talk to those in the thick of it. Here is our Nuclear Engineer Roundtable. Well, welcome to the show, you guys.
Hi.
Thank you very much.
So if you guys would like to tell us a little bit about yourself, your name, and what you're at, and what part of the nuclear technology field are you in, and et cetera.
Yeah, so my name's Mack. I work in nuclear material science at Oregon State University, and my interests are, providing clean energy for the United States and the world in the future. And yeah, so before college, I went to the Army, and I was a carpenter and combat engineer. So I've used explosives and built things, and then I came back home, and sure enough, went to school to become a nuclear engineer.
How about you, Sarah?
So my name is Sarah Woolf, and I am carry a few hats. I wear a few hats. I'm the codes programs engineer, a fleet ISI engineer for Exelon Corporation in the private commercial energy, nuclear energy fleet. And I also am the director of East Coast operations for a nonprofit called Mothers for Nuclear that is a pro-nuclear environmental organization. And my background, I started fresh out of college into the nuclear industry. Before that, I worked with the Department of Energy on some wind turbine research out of Iowa State University, and decided that that was not really where I wanted to be. In the energy sector, I wanted something that was a little more practical on a large scale use. So I came back to New York, and I had a job at Gen Nuclear Power Plant, worked there for a year before transferring over to Fitzpatrick Nuclear Power Plant as an ISI programs engineer, which essentially is a blend of law and engineering for materials engineering. So I came back to Gannett and Exelon as a fire PRA engineer, probabilistic risk assessment. Missed codes programs so much that I bounced back over to it about 4 years later, and I've been doing that for 3 years again, and I love it. So I'm a nerd.
Awesome. Oh no, nerds are what makes the world go round. So we need more of you guys. So awesome. Well, what about you, Jason?
Well, I originally wanted to pursue a career in alternative energy. I lived in Colorado throughout high school and after high school for a little bit, and I was starting to look at schools, at colleges, see what I wanted to do. Arizona State University popped up with a program called Engineering Technology for Alternative Energies. That's the one that really caught my eye, so decided to move to Arizona and start taking my prereq classes to do that. Well, it was during my prereq classes that I had one physics professor in particular that influenced me a lot. Just he has a doctorate in nuclear engineering, and the only sentence he had to say that made me change my whole outlook on nuclear power was that a banana is more radioactive than if you went and stood next to a spent fuel cask. And yeah, that blew my mind. So I started researching that immediately. And yeah, that took me down the path of wanting to give nuclear power a chance from, I just had a Simpsons idea of it before that. So since I was in Arizona, which just happens to have the biggest nuclear power plant in the country, up until the new ones in Vogel get up and running. Yeah, I eventually finished my associates in engineering technology. That helped me get into an apprenticeship in instrumentation and control at Palo Verde Nuclear Generating Station. During my apprenticeship, I completed my engineering degree, got a bachelor's in science in nuclear engineering technology. And so yeah, 6 years at Palo Verde was my tenure. Then I decided I need to apply my engineering degree so I can be ready for the next gen nuke plants. Next gen nuke plants probably 5 to 10 years away, but in the meantime, all that new technology is very slow to trickle into the current nuclear fleet. Most of the issues are cybersecurity, issues with the modern instrumentation and controls that run nuclear power plants. So I'm currently working for a semiconductor manufacturer where they do use those technologies that eventually will be used in nuclear power plants. Incidentally, they use the same distributed control system that they did at Palo Verde. So, except it's the newest, up-to-date version. So yeah, I feel like it will help me when those new nuke plants come in, and I can't wait.
Yeah, so good preparation for the future. And the next question I have for you, Al, is what got you interested in the nuclear engineering and technology field? Mac, we'll start with you.
Yeah, hi. So in 8th grade, I was touring Oregon State University, and some of the students walking around say, "Hey, you should join nuclear engineering," and I kind of laughed it off. And then, fast forward 5 years, and I'm on deployment in Kuwait and Iraq, and thinking, what am I going to do after college or after this deployment? And so I wanted to go to college, and so I grew up in a scrapyard, so I knew engineering was what I wanted to do. So naturally, I just looked at engineering, different engineers, and I didn't even know there was more than one type of engineering, but petroleum was the highest paying one, and then nuclear was the second highest paying one. And I didn't want to go to Texas and pay these extreme tuitions. So I came back home and took nuclear engineering, and then lo and behold, I found out it was so much more. I didn't know that nuclear fuel is so energy dense. Just for a scale, 1 gallon of uranium, if we fission it all, is worth about 67 million gallons of gasoline. And so I knew I picked the right science when I heard that. And so I was doing ROTC in college, and I dropped out so I could pursue my PhD in nuclear engineering. And I wanted to do material science because we're pretty materials limited for our future technologies. And so yeah, that's what I do. I'm a PhD student in nuclear engineering for material science. That's my focus, and I've published papers in the Cambridge core, and I make YouTube videos that delve into the science of nuclear energy.
That's awesome. And how about you, Sarah? What kind of got you set on nuclear?
Well, I took a kind of a long path to get there. I was really uncomfortable generally with the idea of nuclear power, but it wasn't something I think that I ever gave a ton of thought to. I just, when I was much younger, did a great deal of research into Chernobyl and 3 Mile Island for a variety of different projects. And so I had a kind of the feeling on the subject, if you know what I mean. But I went into school knowing I wanted to be an engineer, getting a mechanical engineering degree. And I actually almost dropped out of engineering school because I don't have an engineer's brain. I'll just put it that way, right? I have more of an artist's brain. And so I'm generally good at math and science, but it doesn't come as easily to me as it does to a lot of scientists, I think. So I really struggled in school to grasp, like I hated mechanics and dynamics and all of the things that were really intuitive to people because they weren't intuitive to me. And then I found thermodynamics, and I just absolutely fell in love with it. It was easy for me and intuitive to me, and it was really weird because everyone else I was in school with thought I was crazy because everybody else hated thermodynamics. And then I got into fluid dynamics, and I was like, oh my God, this is amazing, because it was just such an interesting field to me. So I knew I wanted to work in energy because the idea of designing the volute of a pump sounded really boring. So I wanted to work in some sort of energy field. and I'm an environmentalist, so it was never going to happen that I was going to be working in a coal or a gas plant. So really my options were pretty limited there, and I started taking courses and projects in designing various different forms of energy efficient technologies like point of use wind or refrigeration systems with wind power, or solar thermal and photovoltaic technologies. I wound up going and working with, like I said, an REU out of Iowa State University to do research on new and upcoming technologies in wind power. And I just kind of got really disgusted looking at the industrial use of them because they're not efficient at all. And photovoltaics and solar farms are even less. So, and so I just kind of decided, all right, we need something different. And I had a job offer to work for Gannett, and I went into it very uncomfortable. When I had my interview, I asked so many questions that now are so obvious to me, but then just seemed like such normal questions to ask. And the guys that were interviewing me kind of laughed at me a little, because once you've been working in nuclear for a while, you just kind of understand it. And you're comfortable with the idea of dose and radiation, and everybody else, that's terrifying. So, well, a lot of people, it's terrifying. So they explained all those things to me, and I went ahead and worked in it. Just out, because frankly, when I started, it just seemed like an interesting venture, and I wanted to give it a chance because it seemed like the only thing that could potentially make a difference in the energy industry with respect to zero emission power. And I just instantly fell in love with it. And I just started diving deeper and deeper into it. And the more I learned, the more I loved it. And after my first 9 months there, I started looking around for other places to go and other jobs. And the person I was working with, our career mentor, was so disgusted that I wouldn't look at anything but nuclear power. So I was just sold. I was absolutely in love with it. So, and I've that romance I have with it has not ended. I'm still utterly captivated by the industry as a whole and the technology that we're bringing. And
that's interesting that you were originally skeptical about it, but it makes sense based on some of the rhetoric we hear surrounding it. But that's really cool. So Jason, you kind of touched on this a little bit, but I remember you just talked about how a teacher was a really big influence on you. Would you like to add anything else to what got you interested in nuclear?
Well, I guess I could say the biggest driving factor is that I am from a coastal town in Sinaloa, Mexico. I was raised, kind of born pretty much at sea level. So just the thought of global warming, which is very evident, climate change in general, because, when you say global warming, people like to point at the snow where it hasn't snowed before, is just changing climate patterns. But overall, it's warmer if you average it all out. It's very clear that the sea levels are rising. And just the thought of my forefathers' lands and graves ending up under the ocean, that was something I didn't want to think about. But I don't know. That was a big driving factor for me. My dad was a crop duster pilot in Mexico, and that was one of the main things I wanted to do, was follow in his footsteps and become a pilot. But more important to me is family, and so what better to give my kids a better future, than a stable climate and their grandparents' lands to still be able to visit that, right? So I also saw energy as a giant factor in what makes a civilization great. Or if you compare different cultures and and economies. If it's kind of like in Dune, right? He who controls the spice controls the power, and the spice is energy. And nuclear power is the most dense source of energy that will have the least amount of impacts, on the environment. And pretty much the only thing that can pull us out of this climate nosedive that we're in into a disaster, just because of the energy density. So yeah, that was my biggest thing. Me wanting to originally do alternative energy and get rid of fossil fuels. I wanted to make a difference in the energy industry, and when I found out, as Sarah was saying, the energy density is, it makes everything else look like Mickey Mouse. I was driving by the coal plant here in Colorado Springs today, and I thought, man, like one of my units makes like 10 times more power than that. And it's not, continuously getting trains of coal in every day. But yeah, that was the biggest thing for me. My children's.
Sorry about the technical difficulties. We'll get to the next question here.
Yeah, sure.
And Jason, you already kind of touched on the big issue, which is climate change. And climate change is a big problem. And to you guys, what makes nuclear such a good solution? Yeah, I know you guys have touched on this a little bit, but expand on that if you could. We'll start with Mack.
Hey, yeah. So climate change, right? Climate change is number one. This COVID-19 is number two. So let's start with what climate change is, right? We have too much CO2 in our atmosphere, and that's causing the greenhouse effect. So you got the sun's rays coming in, we can't reflect them as well, so we're absorbing that heat, and as a result, the Earth is heating up too much. So how's CO2 made? Well, if you burn a gallon of gasoline, that's 20 pounds of CO2. So that's kind of a problem. You're producing, and keep in mind, a gallon of gasoline is only 6.8 pounds. So you're actually multiplying your fuel into CO2. And I thought that was crazy when I learned that. And so the alternatives right now, you got solar cells, which take in electromagnetic radiation through the photoelectric effect, and that produces some useful electrons. You can use wind turbines. So if you heat up some air, that makes the air less dense, and then you have some cold air rushing in, and that's how you can produce some electricity. And then there's hydroelectric, so the water cycle, if you remember from school. So you're heating up some water, it produces some low density water vapor, and that floats over the mountains and the hills and rains, precipitates, and collects into a river, into the soil, and that's just essentially a water battery, and then that goes into streams and dams and collects it in a water reservoir, and we can use that potential energy and turn it into kinetic energy through a turbine and then an electric generator and produce some useful electricity. Now these are great. Hydroelectric, if you run out of water, you're going to run out of electricity. Wind turbines, if it's not windy, you got to produce some wind, shut them off, or light up something else. And solar cells, I think the big alternative or the big push right now is to get these on batteries. So I would just like to say these alternatives all run on nuclear energy because they're all powered by the sun ultimately. And the sun is a nuclear fusion reactor. And the quicker people can learn that, I think the quicker people realize nuclear energy is just far more important than just nuclear fission reactors, right? It takes a nuclear engineer to say, like, hey, maybe we need some shielding, or hey, don't stand out in the sunshine, like that's going to give you cancer. And so the sun has been around for 4.5 billion years, providing all the energy we need on Earth. And that's great and wonderful, but it wasn't until, 75 years ago when we figured out that we can do nuclear energy here on Earth through nuclear fission. And so nuclear fission, get a neutron comes in, hits some U-235 or some some we call it fissile or fissionable fuel, and that splits that atom into two fission products. And those fission products contain about 80% of the energy of the nuclear fission in the form of kinetic energy. And you get some more neutrons and things like that. But so that's where we get this energy, and that's directly from the binding mass. So we're actually converting mass into energy, right? And that doesn't produce any CO2. It doesn't produce any greenhouse gases. All it produces is these fission products, and they decay. And I would like to say that we have nuclear fuel that can contain these fission products, and then we also have more barriers, right? So you got your fuel is your first barrier. So if you have like a metallic fuel, that'll contain the nuclear waste, and then you put cladding on it, and that contains the waste. And then you have your core, that's another barrier to release. And then you have these huge dome structures, right? And that's supposed to be like the last layer of defense.
Yeah, so we have these, ways to utilize our nuclear reactions right here on Earth, and we don't need to necessarily rely on just sun-powered machines. So how about you, Sarah? What brought you to the realization that nuclear is a good solution for the climate problem?
Really, there's one thing, and it's honestly it's just capacity factor and the fact that it's baseload power. So, or the energy density, like we were talking about. So, like Mack had said, all of these other baseload power sources that we have, like coal and gas, they're carbon emitting or greenhouse gas emitting. Nuclear energy, because of the amount of energy it produces every year, avoids 506 million metric tons of CO2 emissions every year. That's a lot. That's a lot of emissions that are avoided by using zero emission power. The only power source that offers that is not currently built to capacity is nuclear power. So that's huge, right? So nuclear power is 54.8% of our current carbon-free electricity solutions in the country right now. Next would be wind at 20-ish%, and then hydro at about 19%. Hydro is another zero emission power source, which is great, but it's essentially built to capacity at this point. So the only thing we really have when we're looking forward for sustainable future applications would be nuclear, because it's not current. Like we are constantly coming up with new and innovative ways to employ nuclear power with our next gen reactors. And we have existing reactors that are really well maintained and really well run all over the country that are, still purring away. And the capacity factor aspect of it is something that's really important for just general day-to-day use, right? So the wind and solar are renewable resources, while awesome, I will say, they're intermittent resources. So when the sun doesn't shine and the wind doesn't blow, they don't work. As amazing as they are. So they require battery power or a backup source of power, which is often natural gas, which is emitting and makes essentially renewable resources turn into fossil fuels, which isn't great. But nuclear power is running most all of the time with an incredibly high capacity factor, which is essentially the capacity factor is the amount of time that it is running versus not running. So nuclear is in the high 90s. The others are teetering closer to like 20. so
Right.
That's, in a nutshell, that's really what it is. To combat climate change, you need not only a power source that offsets the carbon, which obviously nuclear does because it's zero emission, but you also need one that is going to be able to handle the amount of power that we need for the period of time that we need it. So you can't really have wind and solar being it, because you need hospitals and you need all of heat in the cold months, and you need all of these things that you can't put all your eggs in one basket and say, hey, we'll use blankets and candles.
Right. Yeah. So kind of through the process of elimination, it's one of the things that's what's left, and it would be just silly not to use it.
Yeah, it's an awesome resource, and with it there and built, there's no reason not to employ it or to, shut things down.
For sure. And how about you, Jason? Why do you think nuclear is such a good solution for climate?
I think it's the only solution that can possibly be built fast enough before we hit the point of no return. Everything else, I mean, even if you used all nuclear power, which I'm not saying we should, right? We should use the other technologies available where possible, just to, throw everything we got at the problem. But yeah, it's just you couldn't build solar panels fast enough, or wind power fast enough. All of those things also are very, very energy intensive manufacturing. Fiberglass for the rotors on wind generators, all of that.
The silicate.
Yeah. On photovoltaics, they are a semiconductor, which is silicon with some doping on it, and it requires a lot of rare earth metals, precious metals that require a ton of mining and are very limited how many we can make. And just in the semiconductor industry in general, it's having a huge shortage because of COVID-19 at the moment, and of course that's affecting photovoltaics too. Not only that, most mass-produced photovoltaics come from China, India, and using slave labor instead of nuclear power, which we can train our youth in useful skills to build these plants, skills that we are losing not only in this country, but we're losing out to other countries, right? I think it would be an economic boom if we tried to focus on nuclear power again. But yeah, I think that's why it's a good solution overall. It's a great economic engine, and it's really the only way we can keep up with energy demand.
Right, and at the end of the day, from what I've learned, is it's relying on just wind and solar. That just takes a lot of machinery, and do we necessarily want to use all those resources, right?
Yeah, absolutely.
I just wanted to ask all of you, why do you think other sources of energy are not enough by themselves to end carbon emissions? You may have differing opinions on this, but Mack, what do you think?
Yeah, so why they're not good enough. So the root of this problem is humans consume too much energy, right? And why we consume this energy is for heating, cooling, and ultimately providing us a good quality of life. And here in America, we have huge energy consumption. We have a good quality of life. We got refrigerators, heaters, air conditioners, things like that. And the rest of the world wants a higher quality of life, right? So as soon as the rest of the world catches on that, yeah, you can live a better life, they're going to need all this energy. And what are they going to do? They're going to go out looking for the easiest source of energy, which right now, coal's literally dirt cheap. And coal is really harmful for the environment. And so if you want to support 6 billion people on coal, that's obviously going to destroy our environment. Now, renewables, they're still in their infancy, and right now, it is a good alternative to coal, but it only takes, as it say, one bad apple, and then, one person burning coal will offset, hundreds of people using solar panels and things like this. So nuclear energy, it just takes one shovel in the ground and somebody to do some science and figure out there's some uranium in the soil, and it's got tons of energy in it, right? And if people figure out how to take that energy from their shovel load of soil and produce it into electricity in a cheap, effective way and reliable, there's tons of benefits to that. And the nice part is nuclear energy, we already got stats for all the safety. We've got stats showing that it's way safer than any other energy source. And I believe the future is all about safety. I don't know if anybody's done construction or anything or any work lately, but the future is all about safety. And I truly believe nuclear energy is one of the most scrutinized energy sources. And as a result, we're one of the safest energy production methods. So that's why I believe solar panels and windmills and dams, aren't going to be used very much in the future.
Right, and I think you bring up a good point about people are going to use what's dirt cheap. And what's cool about nuclear and nuclear fuel is it's in the dirt too, and there's a lot of it. It's dirt cheap, and it's just a matter of heat and water the cheapest way with it. So yeah, that's awesome. Sarah, you went a little bit on about wind and solar too, but do you also believe it's not enough to end carbon emissions to a level of 0?
Oh, for sure. So kind of expounding on what I had mentioned before, the capacity factors for solar and wind are not such that they can replace baseload power. It would be great if someday they were, but at present they're not. The current capacity factor for solar is somewhere hovering around 20%. For wind, it's about 35%. And just to be precise, for nuclear, it's around 94%. So that's a significant difference in how often they are running. And just basically, there are a couple things, like I said before, your ability to run all the time and handle the amount of energy load that's brought about by the world, right, is important. Otherwise, we won't be able to power our hospitals and our lights and our heat and all those other things that life requires and life demands. And short of everyone going on some kind of giant energy efficiency diet, we're not going to see great reductions in our energy loads. They just will increase. So
Got it.
I really don't think that it's practical to think that our energy demand is going to reduce significantly. But per Mack's point, what he was talking about with the evolution of other communities and wanting to have a better quality of life and striving for that, there's a theory that I will touch on very briefly called eco-modernism, where it's essentially a blend of humanitarianism and environmentalism that says that, it's really not fair for the developed countries and communities and cultures to tell a third world country that's developing to have a good standard of life or living that they cannot do that because, well, we have all these emissions, but we don't want you to muck it up for the rest of the world. So you don't get to have the same kind of development scheme that we had as countries that are currently, first world countries. So
it's kind of the equivalent of saying let them eat cake.
Yeah, exactly.
It's just tone deaf.
Exactly, and it's a kind of an idea where we want to develop technologies to make it so that it's affordable and reasonable for those kinds of cultures to use something that is less emitting as soon as possible. However, we want to implement those kinds of things as well in the developed countries so that these people have an opportunity to develop. And, it's not really fair to shove their face in the dirt and go, no, this is only for us. You may not have a slice of pie, So,
Right.
So just a little tidbit or idea of philosophy that we carry.
For sure. And Jason, do you also believe other sources of energy by themselves are not going to be enough to end carbon emissions?
I believe that very strongly. I had a very surreal experience while I was working at the utility company in Arizona. I was at the 25th or whatever, top story floor where the power traders, energy traders, sit when a dust storm, a wall of dust, started rolling in. I could see on their monitors every power generator that our utility owned, including nuclear, fossil, and solar. And you can see the output of each plant. And as that wall of dust rolled in, the output of those photovoltaics and the solar concentrators just tanked, absolutely tanked. And I saw them in real time, like I was there as I saw this wall of dust coming, and they started calling, we need to buy more power. We need more power from all these other merchant plants, and calling to start up the gas generators, right? So, yeah, as the climate situation gets worse, these alternative energies are not gonna, they don't withstand the bad weather that this climate situation is bringing. And there's, if you look at the number of hurricanes and storms and the intensity of them, how it has been changing over the past 20 years, there's a clear trend that they are getting more significant, more powerful. The hailstorms that have been happening in Colorado, you get baseball-sized hail that could absolutely wipe out entire, photovoltaic fields. So no, those technologies are not anywhere as resilient as a nuclear power plant, which can keep operating at 100% power through the heaviest storms down in the south. That when the tornadoes and hurricanes hit, those are the ones that stay up because they're, as Mack was saying, they're the safest technologies. They are so tough, built extremely tough. Of course, there's lessons learned. Fukushima, everybody knows. Don't put your backup generators under in the basement where they can be flooded by a 50-foot wall of sea, sea wave.
I would just like to mention that nuclear power plant failed by a diesel generator, right?
Oh, yeah, all their backup diesel generators and backup switchgear were inundated by water. It's a very specific failure that we definitely learned from and are applying our knowledge from. But yeah, that's why I don't think other technologies are going to be enough, because they won't withstand the climate change.
And yeah, and I think you bring up a good point about how weatherable some of these technologies are. Like wind blades and photovoltaic panels are pretty fragile, and they can get damaged pretty easily. And a good example would be Puerto Rico after Hurricane Maria came through. You see pictures of solar fields just destroyed. And the idea from many people is like, oh, well, they just need a more resilient grid with wind and solar. And I'm like, at the end of the day, it's like, is that really going to withstand the crazy weather events that we might see in the future? So, I mean, I think that is a good point. And nuclear is very hardened. It's a concrete shell that can pretty much withstand anything except, flooding from a tsunami, which is a very rare event. But, all those things can be taken into account of. So moving on, do you guys feel that more young people will pursue this field because of the climate issue? And do you think a new generation can make nuclear power cool again? We'll start with you, Mack.
Yeah, absolutely, right? Like, I am a new young person in this field because of climate change. And I feel like as soon as people figure out renewable energy is just really inefficient nuclear fusion energy, people are going to start looking for answers, right? And they'll find that nuclear energy is the solution. We're just turning mass into energy, and it's carbon-free energy. And people, once they open their eyes and see that, yeah, like you can't run a submarine on diesel or solar panels or windmills or hydroelectric power. Like if the Navy is going to put nuclear fuel into their submarines, then maybe we should learn from that. And as we go out into space and on the moon and we go to Mars, we're going to see more nuclear power plants on these two rocks. Well, why? Because there's not very much sun. I mean, there's solar panels on some of the stuff, so sure we can use solar, but there's no wind. There's no water out in space. There's no
I mean, there is. It's just frozen.
Yeah, and we could just send up these reactors and turn them on and off, and we can send RTGs that just decay and produce energy, and it's so energy dense that it's way cheaper than sending a gallon of gasoline up into space. Rather, just send a gallon of uranium, and it's worth 67 million times more energy. You're not consuming oxygen that's super precious out in space, and like, I don't know, I like to think here on Earth, we shouldn't be consuming all of our oxygen, right? And if we mess with the wind too much, we're going to pay for that. If we mess with the water cycle too much, we're gonna bite the bullet on that. So I think people, once they get educated, like, they'll come around. I truly believe so.
Gotcha. How about you, Sarah? What do you think about that?
I have a really different view coming from the industry, I think, because I've spent pretty much my entire nuclear career fighting against the premature closures of nuclear power plants based on the market conditions, whether it be in the Midwest with wind power and the wonky way that our ISOs calculate the price of power and the cost of natural gas in the Northeast, or in the East in general. In our unregulated plants, so the places that are we bid for power. The South generally has it kind of locked in because it's regulated. We're seeing our plants close. It's not really, now depending on what part of the nuclear industry you're talking about, with research, yeah, there's all kinds of really exciting things happening. But if you're talking about the existing nuclear fleet, we're dropping like flies. Since I started in the nuclear industry, there have been 7 premature plant closures alone, and we already have slated another 8 to close. That is a huge amount of power. That's a capacity of around 8,000 megawatts electric that have already closed, and about another 8,000 that are going to be closing in the next 3 years.
Yeah, if we aren't careful, in a blink of an eye, we're going to go from 20% nuclear to 15 to 10 to 5. So
exactly. So the way that the nuclear industry kind of works is a tiered approach, right? So the reason plants are closing is twofold. You have the market, so the monetary, which the companies that run them obviously would prefer them to run rather than close them. They have a vested business interest in it, and generally they want to own them and for them to run for sustainable reasons. But at some point it becomes a bad business decision, right? And so they have to kind of cut their losses. Without the existing nuclear plants, there will generally be no future for nuclear because you need the existing plants to build on. So if we have all of these plants closing and the general populace is sitting there going, wow, that's great because they're dirty and dangerous and old and aging and all of these words that are really negative that get associated with nuclear power because they're closing them, and people assume if they're closing, they must be either bad in some way or old and ready to retire. When in reality, pretty much everything but the reactor itself in most plants has completely been refurbished in its lifetime, especially if they've gone through license renewal. So I don't really think that there's a great opportunity for new and upcoming engineers unless they want to be in research, which has generally limited practical applications at this point. It's great to sit there in the lab and try and think up what the future is going to look like, but it would be really cool if we could make the future a reality. So if we don't keep the plants from closing, then we have a pretty limited career outlook for the people that are entering the industry right now.
Right, and it brings up an element of, in my opinion, almost like heartbreak for science is these plants are going to close and there will be no work.
Right.
People that want to enter this, when you think about it, like wonderful science career, and we're at a crossroads, and maybe in my mind, maybe other countries will start taking up the slack. Maybe more young people will help with like the Chinese nuclear program or something.
Yeah, so there's just really no place for people to go right now because people that are my age in the middle of their career, as plants close, they have to go someplace, and we only have a certain number of plants available for them to go to. So people, would rather scoop them up than someone new, and we have all our baby boomers leaving right now with all their knowledge, but people who have been in the industry like me for like 10 years or so we're kind of moving around and just shifting around the country, going from job to job. So essentially, in short, I would say if I have a college graduate coming up to me and going, hey, Sarah, is nuclear a good bet for me in my career? No, it's not. I can't honestly look them in the face and tell them, you know what, I think you'll have a long and good career in nuclear power right now. So it's sad, and it's an industry I really believe in, but the politics and the market just don't support it lasting. So it's really negative. I'm sorry.
At least in this country right now.
Correct.
But
Yeah.
you know, we could see, you know, we might have to take a few losses, but with the right policy and with enough, I think people on more left side of things, you know, the more like left-leaning parts of politics,
I think
they're going to turn around and say, hey, we should go back in that direction, and hopefully that'll give people some more opportunity.
I think there's a lot of hope for that, and I think that, I mean, that could be an hour-long conversation in and of itself.
Right, of course. Yeah.
Where that goes and where that comes from, but yeah.
For sure. Jason, do you think more young people, because of climate change, are going to pursue it, you know, pursue the field of nuclear? And do you think a younger generation could make nuclear cool again?
I'm somewhere in the middle of Mac and Sarah there. Depends what fleet you're talking about. If you're talking about the existing fleet, definitely feel very much the same as Sarah. Most of the old reactors that have been operating are run by Navy nukes, and they run them like submarines. They run silent and run deep. They don't want people to know there's a Navy or a nuclear plant, not Navy, a nuclear plant in their backyard, you know, because of how some people see nuclear power. That makes it so that, you know, most people that work there know somebody that says, hey, this is a good job, this is a good industry, come check it out. So the existing fleet is really hard to get into, really hard to hear about. Like 95% of people in Arizona don't know that the biggest nuclear generator in the country is right there, 45 minutes away from Phoenix. And it blew my mind every time. Like, where do they think all this AC cooling power is coming from? There's only like 6 other little gas generators sprinkled throughout the valley. But anyway, so when it comes to getting a younger generation coming into the field, I'm really hoping for and crossing my fingers for the next Gen Reactors, which, if that happens and there's a nuclear renaissance with small modular reactors that they have better passive safety features, newer technology, all that stuff. I'm really hoping that comes to fruition soon, and that will, I think, hopefully make nuclear cool again. Yeah, new scale, TerraPower, all these small modular reactor companies. I'm really hoping they come to be. Otherwise, like Sarah said, if you get niched too hard in nuclear, then it's kind of a lost degree. But personally, I got lucky where even though my degree is nuclear engineering technology, I also had the instrumentation and control apprenticeship that combined make me very employable in almost any industry. I could go work in any manufacturing, any power generation industry, and that's kind of what I'm hedging my bets on. I'm hoping I can apply what I learn of new technologies in the next gen reactors. I got kind of tired of, I feel I mastered in the nuclear power plant where I was working, I mastered pneumatics control systems, which will probably be used very sparingly in future plants just because they're way smaller. So yeah, here's for hoping for the future.
Got it. Well, these are most of the questions I had lined up for you guys. Now we're just open up for whatever conversation we want for a few minutes here. I have a question for you guys. Do you feel like the fervor around wind and solar is almost betraying the clean energy that we get from nuclear, and that it's all people talk about and they just don't seem to even care that we're losing all this generation?
Man, actually, okay, so this was a huge problem I had. I was looking around trying to figure out why everybody hates nuclear power, right? And And lo and behold, I get my state voters pamphlet and I read the Green Party. I was like, man, this all looks so great, so great, so great. And then the last line, it says, oh, and we're trying to shut down every nuclear reactor in Oregon. And I was like, well, that sucks. And it was like,
Right.
we could do the Green Party, like we could carry all of them so easy. And it's just like, I don't know, I feel like nuclear got a bad rap from like the Hanford project. That thing was an emergency like operation where they're trying to make nuclear weapons and they just dumped a bunch of waste because it was a war effort. And then people somehow think that's like nuclear energy. And there's like, I don't know, we always get, whenever there's a problem, it's like, oh yes, everybody focuses on that. And it's like, but we have so much to benefit and we don't mess up very often. So it's kind of rough. It's kind of rough.
Anybody else have thoughts on that?
Yeah, I do. I really, it's very frustrating as an environmentalist because this really interesting conversation has emerged. So I work a lot in politics with our politicians to try and help them to understand clean energy legislation like zero emission credits and clean energy standards and things like that. I've done a lot of speaking with them and conferencing and things like that to kind of understand the concerns that people have. And I've also worked and lobbied, unfortunately, against people who are environmentalists that are 100% renewable environmentalists, right? And it became, as we were going through the clean energy standard here in New York and the Future Energy Jobs Act in Illinois and the clean energy standard in New Jersey and all of these various different legislations that came out, I was constantly butting heads with environmentalists, which baffles me because environmentalists should be the biggest sellers of nuclear power because it is so huge. Essentially, the premature closures that are going to happen in the next 3 years are going to wipe out 100% of the wind and solar energy we have in the entire country. So, like, what? It doesn't make sense to me as someone who's technically, an engineer. It doesn't make sense. As a numbers person, it doesn't. So it was so frustrating to me. I was in a meeting talking about the closure of Indian Point. Down in Albany, and the person who was speaking was from a very fervent anti-nuclear and pro-environmental group here in the state, and they had said, I want to see 100% renewable option on my energy bill. I was like, great, that's a great idea. You know what? You should have that. And on top of it, you should have a big button at the New York ISO that the person can push when none of those are running that shuts off all power to the people that have that option when they're not working. And then maybe you'll understand that it's not an either or kind of thing. You're using something else to power these things a lot of the time. And it's become this debate between nuclear power and renewables, and they are not at all equivalent. You're talking about apples and oranges. You sit there and talk about coal and natural gas with nuclear power, now you're talking apples to apples. But if you talk about, with respect to baseload power, not them being emitting, but you talk about renewables, they're not the same thing. They can't do the same thing that nuclear power can do. And this discussion at the legislative level has just become constantly talking about, well, renewables or nuclear. No, it doesn't work that way.
Both.
Right. And on the flip side, I think that argument and that back and forth with the renewable community has put this wedge in between pro-nuclear environmentalists and anti-nuclear environmentalists to the point where a lot of pro-nuclear environmentalists have become anti-renewable, which is really sad because, like, I'm very pro-renewables with certain things like point-of-use wind and solar thermal applications. I think they're awesome. Or offshore wind. I love offshore wind, which gets me into trouble with my pro-environmental or pro-bird environmentalists sometimes. But like I
I gotta admit, I've been guilty of being anti-renewable, but my opinion truly is do it where it works and let it compete with nuclear too. Like we are as valid as they are. They're as valid as we are. Most of the time, it depends on the application, like you said.
Yeah.
So
We have to, it's just like a kid. You wouldn't put a kid in a situation where they were ready to fail, right? You want to put them in school, for instance. You want to put them in the best place where they have aptitude to succeed. You don't want to put a kid that, doesn't have any depth perception in front of a baseball. You'd want to put a kid who, has some sort of, you'd put him maybe in, a lab with a beaker. You don't want to put somebody in a situation where they can succeed and they can flourish. It's the same thing with renewables and nuclear, right? You want to put them in a situation where they can succeed. Otherwise, you're just going to prove the naysayers right, and that's not good for anybody. So,
Jason, what do you at all feel like the renewable only crowd has basically, I don't know, betrayed your enthusiasm for clean energy?
Yeah, I mean, I guess that's mostly for the big groups that wield power, or the big individuals, like the Steyer character from California that was trying to pass a 100% renewable thing in Arizona. That would have shut down our nuke plant, absolutely. And, of course, made our electricity bill skyrocket in the state, just as occurred in California. Also, Greenpeace, those type of organizations, I think there's a lot of, I don't know if it's just conspiracy theories. I haven't looked at it deep enough myself since I'm so busy with work and the family, but it appears to me, they're kind of in cahoots with the fossil industry, because the fossil industry recognizes that these are not real threats to
Their bottom line.
Yeah, exactly. Whereas opposed to nuclear, that can definitely replace the long pipeline for electric vehicles, the long pipeline to fossil fuels, which currently in California, most Teslas get a lot of their power from fossil generation, not just solar and wind. So yeah, environmentalists that are like at the individual scale, I just feel bad for them, because I think they're uneducated and ignorant as I was before I started looking into nuclear power. I don't blame them. I think it's a problem with the nuclear industry. Like I said, they run silent and they run deep, and there's not enough effort to bring out the awareness of the technology to the common folk.
Yeah, and I think that's what our goal at Americans for Nuclear Energy is. And listeners want to know, Jason's one of our team members. Our goal is to inform the population about the benefits of this technology and what's so worth saving about it. And it's really great to have you guys all on. And I think you guys give voice to a legitimate field of science that's oftentimes forgotten. And it's good to hear from you. And just to reiterate, I try to say I'm not anti-renewable, but we do have to work together with them, and we can't exclude each other. So thanks for coming on, you guys. Really appreciate it.
All right, thank you, Phil.
thank you.
Yes, thanks, Phil.
All right, well, we'll talk to you some other time. What an awesome and honest discussion with Mack, Sarah, and Jason. We wish them luck in their careers in nuclear engineering and nuclear technology. The planet desperately needs people like this to keep it safe from catastrophic climate change. The usefulness of the field of nuclear and its scientists and engineers cannot be understated. Many climate scientists agree that nuclear has to be a major part of decarbonization efforts. Nuclear power can do things wind, solar, and hydro just cannot. This field of energy is as valid as any other energy field, especially clean energy, and it would be an absolute shame if policymakers let this industry close down in America. Now is not the time to pick and choose what clean energy will be funded or selected for based on the politics surrounding it. It's not fossil fuels versus renewable energy. It is clean energy versus dirty energy that could doom the planet. All carbon-free energy should be supported in a fair manner, without leaving one behind. That is what is happening in America right now. We are letting huge amounts of clean energy and nuclear slip away because of bad policy. This is essentially wasting the talent of our guests today. What we need is society to trust in science equally everywhere. We need to protect our current nuclear reactor fleet. We need to fund and provide incentives for nuclear as much as renewables. We need to stand up for nuclear as a legitimate field. And we need to produce the next generation of nuclear engineers and scientists with a future. We want to thank our guests, Mack, Sarah, and Jason, for taking time out of their busy schedule to talk with us. Thanks for listening to our Nuclear Engineer Roundtable. This is Phil Ord, signing off.
If you like what you heard and want more content, you can support Americans for Nuclear Energy's Climate Fix podcast on a per-episode basis with Patreon. Link in the description. To support Americans for Nuclear Energy and our general mission, visit our website at www.americansfornuclearenergy.org. All words. Again, that's www.americansfornuclearenergy.org. We have a link to donate with PayPal under the Mobilize page. You can also purchase some Americans for Nuclear Energy swag under our store page. This will really help us pay for the little things, especially online service fees, to keep our organization running. You can follow us on Facebook, Twitter, Instagram, Tumblr, and YouTube. Lastly, we really want your feedback. Let us know your thoughts, questions, and concerns. We have a message form on our website under the About section, or you could email us directly at main@americansfornuclearenergy.org. All words. Again, that's main@americansfornuclearenergy.org. Thanks for tuning into this episode of Americans for Nuclear Energy's Climate Fix podcast. We'll see you next time.
Edited and produced by Jonna Adams.